Hi everyone, my name is Linda Lee and currently I am a graduate student majoring in electrical and computer engineering in University of Florida, and this presentation is for the course Imagine Processing and Computer Vision course, and I was tutored by Dr. Dapeng Oliver Wu. And in the first part, I just want to do a demo because I think this is the most important part in my project because I finish a Android app. I think it is a comprehensive app including the front end and back end, and it can do the operations for the real image. And the first thing I want to say that is that this app is actually use the Parse platform. Parse platform is published by the Facebook. It is a cloud data platform, and we can see that these are the different of classes like users, and here is what I use images. And here are the images, and each image will belong to different kind of users, and most of images in this class belong to lead user. And actually our app is also run the user lead li user, and we can actually we can log out and choose some other users such as lee, and we just do a demo here and use the li user, and we will click the select and wait for a second. Okay, here is the image stored in the Parse platform, and this app will show the image belong to this user, and we will promise that each image of each user's image is private, though it is in the same class, but it won't show on other users app. And here are the users belong to LID, and we just choose one of them. Oh, this is a pretty girl, so let's choose this girl to do some I think interesting operations. So choose it, and okay, we choose it, and we can see that on the screen there are 4 different type of operations like separator. It is actually the watershed image segment, and noise, it is actually the filter. Use the Gaussian filter to filter the image into the black and white format. I want to say here is that actually I first pre-process the image into the black and white format and do the watershed. I didn't use the colorful image because black and white is more simple than the colorful image. Because I finished all the codes in this Android app, so actually I take a lot. It takes me a lot of time, and I didn't have enough time to finish the colorful part. And also I finished the function like face detection. It will detect the face on the image, and some other basic operations. It is some minor functions, and I want show I will note them here. And first let's take a look of the Gaussian filter. Yeah, filter it. Okay, it will transfer the image into the black white and do the filter and do the operations such as obfuscation to make an image apt to do the watershed segment. And go back to the front page, we will use this Gaussian filters image to do the separate and start watershed separate. Here is the watershed separate, and actually there are some shortages. It is not good enough because it exists the exists the situations like over segment. take a look of here, and the S, it is all segment. And actually I do some improvement, but I didn't integrate this improvement into this app, but I will show you in my next in later in the PPT PowerPoint. And here is really great and interesting function which is face detection. It will detect face. So take a look. Actually there is two circle on it. Why there is two circle? Because first I just my program will catch the S in the image first, and then we will evaluate the proportion of face. So we do the eye catch first and then detect the face. So here is the reason there exist two circles. It is used to detect the eye. And here is the basic demo part of my app. I think though it may look simple, but actually I take a lot of time in it, and I think it works, and it is comprehensive, and it includes the user part, the database, and it catch a lot of exceptions such as data format exceptions. So I think though it is simple, but we can publish it into the Android store. And let me to introduce you about the basic theories behind these operations. And let's begin. Oh, sorry. Here is the PowerPoint, and we already seen that there are three basic functions, which are noise filter, watershed image segment, and face detection. And here's the basic structure of this app. It has a main US, and here is the database. You can choose the image from user's private database, and you can do three operations: filter, watershed, and face detections. All are, I think it is quite complex and interesting. And let me introduce it one by one. At first, when I do the watershed segment, I found that if I just directly watershed the image, the performance is really bad. So I must do some filters, and this is a reason for me to try different kinds of filters. And the first filters I try is mean filter. It's the reason I try mean filter is that it is really simple. We also call it average filter. And I think it just replaces each pixel value with the mean value of the neighbors. So this is a kind of convolution filter, and as you see, it's really simple, but the performance of this filter is not good enough. Actually, it's really bad. So I try another filter, which is median filter. It's similar as the mean filter, but actually the performance of median filter is improve a lot. Though it has a little change from the mean filter, but the performance is really good. We replace each pixel value with the median value of the neighbors, and as we seen in this feature, it contains some abnormal values, and this won't influence the whole view of this area. We want to create new unrealistic pixel values. So this is the best feature of the median filter, but it is simple. So it is, though it is better than the mean filter, but it is not good enough. So we try another kind of filter, which is Gaussian filter. Gaussian filter modifies the pixel value by convolution with Gaussian function. We can see that the values in these little cubes are in the Gaussian distribution, and it removes hair special frequency components from an image. So it is It is better enough for us to do the pre-processing of an image before the watershed segment. And after we choose the Gaussian filter, it is time for us to take a look of the watershed segment of our image. So let's go. So though we already decided to use a Gaussian filter, yeah, but actually I used a two-dimensional Gaussian filter here because the image is two-dimensional, and I combine two one-dimensional Gaussian filter and make the operations such as obfuscation and make sure not exceed the exceed the values of this pixels won't exceed the bound. And here is the codes of the two-dimensional Gaussian filter. If you are interested in, you can take a look after this presentation. Yeah, I will publish all the source code, the PowerPoint, and final report into the e-learning website. And the first step for us to do the watershed image segment is to select the seed area. And the first thing we should do is to get the gradient image. We should use the Sobaya operators to get the gradient image of a black and white image. And what is Sobaya operators? You can take a look of my source code, and I want to introduce more about Sobaya operators in this presentation because it is manner. And in this, you can see that actually I use two ways to choose the seed area. One is threshold and another is disjoint set. First, in the gradient image, the pixel gray value which is less than the threshold we already designed, we should mark it as a 0. We should regard it as the seed area. And we should mark all the areas which value are less than the threshold, and we will regard it as the seed area. And then we should do the first growth. The method we use here is disjoint set. If you have the algorithm foundations, it is not hard for you to imagine how things do here. We combine the pixels together by the disjoint side to find their common parents or ancestors and combine all of them together. And here we can see that sorry. Here we can see that the black area is actually a seed area we already choose. And actually this is the second step of the watershed segment. We select the seed area, and the next step is the core step of the watershed segment, which is the area growth. Actually, we do 3 loops in here. First is the gradient value from the threshold to the maximum value, and another 2 loops is traverse the two-dimensional image. Why should we traverse the two-dimensional image here? Because we want to find that we want to check that each pixel, if there is one pixel which doesn't marked as a 0, so it is not a seed area. But there only exists 1 0 pixel in its neighbors. We will classify it into the seed areas. So maybe you will ask that if there exists more than 1 0 pixels in its neighbors, what should I do? At this condition, we will mark it as the borderline. And here is a basic method we use to do the area growth. And of course, the growth must have a stop conditions. So we will make a judgment. If there doesn't exist the seed pixels classified into the new seed area, we will think, oh, the loop should stop. We will already finish the area growth, and we can take a look of the of the original image and the image after the area growth, we can find that there exists a condition which is an oval segment. So let's take a look of this as actually it was divided into different parts and it is oval segment. It should belong into one part. So what should I do here? After the area grows in a segment, we will do the area combination. So actually, I didn't finish this step yet. I'm still trying the different methods, but the basic method I used here is to find that if the two area has the same size and the value of these two area are similar, we will combine these two area into a new one area, new combination area. So we can take a look. Here is the original image, and here is the image after this area combination processing, and we will combine this eye into the whole new area. And yeah, you can take a look. Things are much better, but I didn't integrate this part into my Android app yet. I will integrate it into my Android app later. And here are the whole basic view of the watershed segment, but it actually includes a lot of algorithm and methods and more than 1,000 source code. So if you are interested in it, you can take a look of my source code and take a look of my final report. It includes a lot of details about how I implement these algorithms, and you will find a lot. And the next part is the face detection. As I said, that I use if I read the image, the first thing I do is I try to catch the eyes in this image. So there may have different features such as color, gradient, skin, eye, and nose. We can use to these features we can use to find to do the eye detection. But I use the most simple one, which is eye. I first catch the eye features and use the position of eye to evaluate the face position. It is quite simple, and it must exist some problems, such as if the eye's proportion in an image it is too small, we cannot find the face for image. And yeah, it has some shortages, but actually it works for most images. And here is a basic view of my Android app. And actually I do a lot of work, and actually the teacher assistant and Dr. Oliver Wu gives me a lot of helps, and his course is really interesting, and I spent a great semester on image processing, and I do a lot of works and jobs. Yeah, I really love this course, and here are the whole works I do for this course. Hope you will satisfy with what I do and what I say. So thank you very much.